everyone, so in this video we're going to talk about how to come up with an equation for a circle. In particular, a circle that's on a coordinate grid. So if anything's on a coordinate grid, as in like an x and y axis here, we can come up with equations for it. For example, a line looks something like this with a slope and y-intercept, and every single point on this line makes that equation true. With something like a quadratic, again, you have an equation and every single point on this line, like if I plug in the x value 3, I'm going to get out 0. If I plug in the x value 3.1, I'm going to get out about 0 point something. If I plug in the value 4, I'm going to get out 5. Every point on this graph makes this equation true. So let's talk about circles. Circles are not functions because they don't pass the vertical line test. Like if you passed a vertical line through them, you'd hit multiple points at once. So they're not a function, but we can still come up with an equation for it, just not a function. So here's how that works. First of all, just pause for a second and see if you notice a pattern between these circles and their equations. So this is the equation for this circle, that's the equation for that circle. You may have noticed a connection between these numbers and the center of the circle, and then between this number and the radius of the circle, which is exactly what's happening here. You may notice it's flipped also. So I had -2, -3, and the opposite of those numbers, 2, 3, is the center of the circle. So that's pretty much it. Or let's see if you notice anything here as well. This circle's center is 0, 0, and it has a radius of 4. Okay, so what you may have noticed is this. The center of the circle, which we often call HK, just because we had to give them names. H is the x-coordinate of the center of the circle. K is the y-coordinate of wherever the center of the circle's at. What you do is, you're going to do x minus h squared and y minus k squared, which basically flips the signs of h and k, and that equals the radius squared. So whatever the h, k, and radius are, you basically just fill them in, and this is on your formula sheet, so you don't even have to remember that. Although this one is sometimes on stuff like the ACT or SAT, so you may want to memorize that. For example, let's say I want to graph the circle that has this equation. I know that it's going to have a center at -3, +4. Because if I plugged in -3, 4 here, x minus -3 is how it becomes x plus 3. And if I did y minus 4, that's how it becomes -4. So basically you just flip the signs of those, and that tells you the center of the circle. So let's go to -3, 4. 3, 1, 2, 3, 4. That's the center of the circle. And then it's tempting to say it has a radius of 4, but remember, whatever's on the end is the radius squared. So the radius squared is 4. The radius itself would be the square root of that, 2. Basically, what squared gives you 4? It's 2. So this is the center, and then it's got a radius of 2, so I'm going to kind of just go out 2 in each direction. It would also go out 2 in this direction and here, and it would be 2 in each direction. And so just kind of connect the points as best you can, and there's our circle. Also, it says identify the center and the radius. This is the center, and this is the radius, 2. Go ahead and pause the video and try this. Then you can unpause and watch me go over it. So the center for this one is -10, +8. The radius is the square root of that, which the square root of 1 is just 1. On this one, there is nothing in there with the x. There kind of is no h. And so the x-coordinate of the vertex is just a 0. And then negative 17 turns into positive 17, so that's the center. 0, 17. And then the radius is the square root of 18, which I'm just going to leave as the square root of 18. We could get a decimal out if we wanted. Square root of 18 is approximately 4.24. Or you could even break it down into 9 and 2. Square root of 9 is 3. So square root of 18 or this, that's the radius. And then the center for this one, since there's nothing in there with the x and there's nothing in there with the y, this one's actually centered at just 0, 0. Anytime you have just x squared plus y squared, that circle starts at the origin. And in this case, I have 1/4 as the radius squared. Remember, to kind of work backwards, you're going to have to square root. So if I square root this, I'll have just r by itself. The square root of 1 is 1. The square root of 4 is 2. So the radius is 1/2. All right, let's write an equation for this circle. This circle has a center at 3, -1. So as I fill in my equation, I'll fill in 3 for h and -1 for k. So I'll have x minus 3 squared, and then y minus -1, which turns into just y plus 1. And then the radius, I'll need to just kind of count here. How far is it from the center to any point on the circle? It looks like it's 1, 2, 3, 4, 5. Let's just make sure. 1, 2, 3, 4, 5. Yeah, so the radius is 5. So on the end of my equation, I'll put 5, well, let's do this. 5 squared, which is actually 25. So this is my equation for this circle. Let's see if there's anything else. Just so you know, this is a pretty nice form because it tells you the center and the radius. Sometimes when you see equations for a circle, they're all multiplied out. So for example, if I actually did x minus 3 squared.
Teachers, excuse the interruption. They're going to be working on the fire system in this next few minutes. We don't expect the alarm to go off, but if it does, we'll just disregard it. Just want to give you a heads up that it might go off, but they don't expect it to. So if it does, just disregard. Thank you.
Okay, so all I'm doing is just multiplying this stuff out. Squared means times itself. So I just multiplied that out and got this, and now I'm going to multiply out the y stuff, which is y squared plus 1y plus 1y, so plus 2y, and then 1 times 1 is 1. So basically, once you multiply all this out, you end up with x squared minus 6x. The 9 and the 1 we could combine, so in fact we could even rearrange it and do x squared plus y squared minus 6x plus 2y plus 10 if I combine those constants, and it equals 25, which I might even move that over to the other side to combine with that stuff. So it's possible to have this all multiplied out, and in which case you'd want to go backwards and get it to look like this so you know where the center is. But we're not going to talk about that in this video. Also, this isn't a function because you've got x squared and y squared, which is different than what you've seen before. If you want to solve for y, you end up having to take the square root of it. And basically when you take the square root, you have a plus and minus version. And so if you wanted to like graph this in your calculator, you would have to graph it as 2 separate functions. The positive version would be this, because that passes the vertical line test. And then the negative square root version would be this bottom part, which also passes the vertical line test.